Okay, so let's talk about the PCR a little bit more specifically here, okay? The polymerase chain reaction test was invented by Dr. Kary Mullis from Berkeley in the early 80s. He won the Nobel Prize for inventing this test. This test is touted by the medical profession then and now as the gold standard for diagnosing microbial disease in patients.
PCR tests have been around for decades. They are the gold standard for testing viruses because the process is highly sensitive. It can detect even a tiny amount of virus in a sample.
They claim that it can specifically differentiate any viral disease from any other viral disease by sequencing the RNA and DNA. This claim is constantly made even today, and it is completely insupportable and untrue. No one was more critical of the PCR test than its inventor, Dr. Mullis. It was disavowed from the very first. Here's what he said, quote, "Quantitative PCR is an oxymoron. PCR by its very nature is unsuited for estimating numbers. A common misimpression that the viral load tests actually count the number of viruses in the blood. These tests cannot detect free infectious viruses at all. They can only detect proteins that are believed, in some cases wrongly, to be unique to HIV. The tests can detect particles of viruses, but not viruses themselves," unquote. Such extravagant claims have been made over the past 40 years for the PCR test by organized medicine that there has been no other technology developed in that entire 40 years which claims to make any improvement on the ability of the PCR tests to identify and sequence viruses and bacteria. And yet, this is the pitch used today by whom? Everybody. Doctors, hospitals, medical journals, everyday media, TV news, the bureaucrats. Everybody is making these same false claims about this magic golden box, the polymerase chain reaction test. This is the epitome of junk science. Let's ask this question. Where's the science? Is the polymerase chain reaction test, is it closer to science or closer to science fiction? The claims are what? That the PCR can identify the exact RNA sequence of any virus, of a disease virus, right? They can then compare that sequence that they read on an electron microscope, make a micrograph. They can then print that sequence out and then compare sequenced viral samples from patients, right, with that master sequence, looking for an exact matchup. And an exact matchup would determine whether it was a positive test. Did this patient sample have the exact same disease as the master sample? That's what they have been claiming all these years.
To test someone, you first have to swab deep into their throat and nose to collect cells that potentially have the virus. The sample is then added to a lysis buffer, which breaks open the cells so that the viral RNA can be extracted, if it is present. The viral RNA is then amplified by transcribing the RNA to DNA using an enzyme called reverse transcriptase, and then allowing the DNA to replicate many times. Then, short fragments of DNA that are complementary to certain sections of the viral DNA are added, called primers. These primers will attach themselves to target sections of the viral DNA if it is present in the sample. Also added to the mix are small sections of DNA called reporters, which contain a fluorescent marker, which will bind to the DNA near the primer. A polymerase enzyme then latches on where a primer has bound to a strand of DNA. The enzyme moves along the strand, adding complementary nucleotides until the strand is copied. When the polymerase reaches the reporter sequence, a fluorescent probe is released, creating an optical signal that the strand has been copied. As more coronavirus genes get amplified over time, the fluorescent lights glow brighter and brighter. You can't physically see the fluorescence, so the RT-PCR machine records spikes on a graph that tracks the glowing as it gets brighter, revealing whether the sample contained the coronavirus. Negative results won't show the spikes.
Here's how the PCR test works. A DNA helix is cleaved, so it's separated, right? You take a section of one of those strands, and then you begin to double it, because it's very, very small. The PCR test can double it. That's what it does. And then you double the double, and on exponentially like that. And finally, something very, very tiny becomes visible, supposedly measurable. Now, of course, the coronavirus is RNA, so that has to be, like all viruses, right? So that has to be converted to DNA by reverse transcriptase, and that's what RT-PCR stands for. Every time they double a section of RNA, that doubling is called a cycle, okay? So they keep doing it and doing it, doubling and doubling it, cycling and cycling. The test counts how many cycles until RNA is detected, and then they keep on doubling it until the RNA disappears. And this range of numbers, that's all that the PCR test really does. It gives you a range of numbers. That's all the PCR test does.